All right.
Hi, mini class.
I'm in the teacher. I said Mr.
We're missing more than I thought. I thought there were 7 people missing.
There's also signs.
Huh?
People are also
I know.
watching at signs.
I thought there were
and
7
colors.
people missing. We have 16. I expected 9 to be here. I don't see 9.
And Moshe's also not.
Anna's
Moshe-
sick.
And Moshe is.
Moshe is something.
Moshe is.
Hannah and Moshe are
Where's John?
not here.
College. Oh, college bowl and science fair. Yeah.
So Eric, I know. I don't know what else. Nina, Lisa, Max, I saw also. What about Evan?
Science fair. Science fair.
And Jonathan Greenberg?
Science fair.
And Russell?
Science fair.
College bowl.
College
College
bowl.
bowl.
Sorry.
Are you guys making this up as you go along?
So what they told us.
And, you believe everything. And Jason?
Science fair.
Jason? Yeah, science fair.
College. Alright. So I'm marking 2 people now.
Science pool.
Come on. Okay.
You just got it, John?
It's Ben's birthday.
It is.
Who?
Ben.
Well, happy birthday.
He's 18.
Wow, big number.
It really is. It's a birthday.
It is a big number.
Who's here? 18. Go buy small tickets. You
Shut this down. So today I'm going to just spend a little bit of time clarifying what I only kind of zipped over about an absolute value of the series. So, and the absolute value test, the ratio test for absolute value. I just want to spend a few minutes explaining it in a clear way, because I didn't really have a chance to do that before. Imagine you had a series, and it had some negatives in it. And you said, you know what, I don't know whether it converges with others. I can't use the alternating series test. Why might I not be able to use that test? Well, maybe I try to use the alternating series test, and it looks like it doesn't converge. Remember, the alternating series test is not a test for divergence, it's only for convergence. So if it doesn't pass the test, you don't know what it does. So suppose I said, I'm going to take the absolute value of every term. That new series now is blanker than the given series. It's very blank, for sure. And suppose now that I've taken the absolute value, it's now a positive series. What does that mean? I mean, all the other tests are good now. Because all those other tests are good for only positive series. And suppose it passes one of those tests as a positive series. If it converges absolutely, it converges. Does that make sense?
Yes.
It's even smaller because some of its terms were negative. But if we know it converges, then it converges.
So converging is bigger. So then the smaller.
I'll say the whole thing again. I have a series that has some negatives in it. I don't know what it does. I can't use the positive tests, all the other tests, because they're only for positive series. So I look at the absolute value of every single term. It's called U sub n and absolute value. And I try the ratio test, the integral test, whatever I try, because now it's all positive, and passes one of those tests. It now converges absolutely. I can come to a conclusion and say, therefore, the whole series converged, even in its original form. And in fact, I don't know what it converges to, but certainly less, a smaller number than it would have if I took its absolute value. Question?
If it is just the regular series and you use any test, why do we use the ratio test?
Why do we use the ratio?
Because every time we've done absolute value.
Oh, we don't have to. We can use any test. We don't have to use the ratio test. But there's a specific one called the ratio test for absolute value. And it's only if it lends itself toward the ratio test. And oftentimes it does. Yes, ma'am.
So in order to use the ratio test for absolute convergence, you have to have negative terms.
No. You wouldn't use it if they're all positive. It would be redundant. Why take the absolute value of every term if they're already positive?
And so you can't use the regular ratio test on negative.
No. Because all those other tests are only for absolute value. Again, only for positive series.
Can you use that to prove it's divergent series? Absolutely.
No.
Because it will get bigger.
So it's a great question. So let's just follow that thought. And the answer is no. So now I have a series of some negative terms in it. And I try to take the absolute value of everything, and I find that it diverges. And one of the tests showed me that it diverges. Maybe it's a p-series, whatever it is, shows me it's divergent. That means in its positive form, where all the terms are positive, it diverges. But what if half the terms were negative? It may be that with negative terms, in fact, it does converge. So if you tried that, and you found that it seems to diverge when you took the absolute value, I would say maybe it's strictly alternating. Maybe I could apply the alternating series test to that one. And maybe that one will work. But I really can't come to
Can you
it.
take the negative absolute value and then use the test?
I don't know what that means.
Absolute value of use of n and then a negative in front of it.
So that doesn't make any difference.
then the
if you
whole
had-
series would be
It doesn't
small.
make any difference. Because if you're taking every term absolute value and then sticking a negative in front of it,
It would make everything smaller. And then
no. So let me describe it this way. If I look at the series 1 plus 2 plus 3 plus 4, for sure it diverges. Yes? That's the series of n. Okay. So suppose I put a negative in front of it. That makes it smaller, but it still diverges, because now it's negative 1 plus negative 2 plus negative 3 plus the negative infinity. It diverges as well. If you have all negative terms, you could simply factor the negative out in front of the sigma anyway and determine what the series does. So if we had a series that converges to 0.7 or to negative 0.7, it converges. It doesn't really matter to what it converges.
Okay, but if you don't know if it's alternating or not, if there's some negative.
You'll know if it's alternating because it has to have in it negative something to the k.
No, I'm saying if you know it's not alternating, but there are some negative terms.
Then you can't use the alternating series test.
I know,
And you
but
may just not know what that one is.
can you? I'm saying, can you take that series with some negative, take the absolute value, and then take mitigate that, so you get a smaller series, and then test for divergence. And if the smaller series
No, because the
diverges,
only tests you could use now are tests for positive series. All the tests that you run, except the alternating series test, are for strictly positive series. Yes.
Is it possible to find out if it diverges to negative infinity? Because if you realize that it diverges to negative infinity, then when you add in the absolute value, if the absolute value diverges to negative infinity, then when you add negative numbers, it's still going to diverge.
If you took the absolute value, there's no way you could get negative infinity as an
That's
answer.
true.
It's
It's
impossible.
possible.
All the terms are positive,
Yeah.
so that can't be. You might get infinity,
But that's not.
but again, although it might seem like it's likely that that series, which had a few negative terms in it, not strictly alternating, but had a few negative terms. Oh, I have an answer. That might answer your question. If you just tried the divergence test, and you found the limit was either +2 or -2, anything other than 0 would diverge. Plus infinity, negative infinity would diverge. The only way a series can converge is if when n goes to infinity, if the terms get tinier and tinier and tinier, then it has the potential to converge. So if you just try the regular divergence test, even if it had some negatives in it, but you need a general term, that's a problem. So you'd have to look at the general term, take a limit, and if it went to anything other than 0, it converges. It's hard to get a general term unless it's strictly alternating. Yes.
Why did you say that it converges absolutely?
So, because we're applying the absolute value to every single term. That's one.
I don't
It's
like
not
that.
the English word absolutely, we mean it in terms of absolute value.
Okay.
And if it converges absolutely, then it
Why
converges.
don't you say what, do you say, how come you don't say diverges absolutely?
If you took the absolute value of every term, and you found that it diverged, you don't know that your series diverges. You cannot make that conclusion. Maybe there are enough negative terms to bring it down to converging towards something. So you can't make a conclusion.
So you can never say diverges.
There may be series that you just don't know what they do.
Well, let's say you do this test, you'll never know if it diverges, like.
That's correct. I'm going to try one more time. I know it's a hard concept. If you took the absolute value, some negatives in there, you took the absolute value, and it doesn't converge, it diverges, then you don't know what the original one does. That does. It may be likely that it diverges as well, but you don't know.
So after you do, would you have to do another test?
If there are negatives in it, the only option you have is if it's strictly alternating, then you can apply the alternating series test. And maybe it passes that test and converges. So, and the ratio test for absolute convergence just means you use the ratio test, but you took the absolute value. We actually did that when we went over that question that was on the test. Remember there was a -3 to the k? So once you take the absolute value of the general term, which is 3 to the k, and it converged. Therefore, it converges absolutely, so it converges. Okay? I may have a question. But I don't think we did this question. So once you use the ratio test, that's helpful because the ratio test, you know, if rho is this, it converges, if rho is that, it diverges. Yeah?
Yeah.
So suppose we look at a series. -1 to the k, 2 to the k, k factor.
Is it from 1 to infinity?
So because these are unrelated one to the other, the numerator and denominator, the only test that makes sense is the ratio test. There's no way you can integrate it. It's just, and it is infinity over infinity. You can't take a derivative of the factorial. So let's just try rho. Limit as k goes to infinity of the absolute value. And now it's the new term divided by the original term. Yeah? I'm going to write it. What's the new term?
2 negative
-1.
1.
To the
To the k plus 1.
And
From
then
2
2
to
to
k
the k
plus
plus
1.
1 over
For k plus 1 and factorial.
and
Time
divided by so times its reciprocal, which
k
is
factorial over 2
so because it's an absolute value, and it's just a 1. We realize it's -1, but we take its absolute value and totally ignore it. So let's look at the rest of it. Does anyone see what's left here? Yes,
So we 2 over k plus 1.
certainly. Anybody have a question on that? Take the limit, and we get?
So the -1 to the k plus 1, since you took the absolute value, it's 1 and
Really, if you just divide these, you end up with a -1.
3.
But that's absolute value, it's just 1. These are like terms, you can subtract exponents, right?
So it's always going to be -1, but since, okay, I see.
So we're taking absolute value. So because we got 0, rho equals 0, conclusion?
Absolutely.
Absolutely.
Now we say convergence
Absolutely.
absolutely by
ratio test.
ratio test for absolute convergence. Therefore, it just converges. concept that I was trying to get. If it converges when some of the negative terms are now positive, and it still converges, and certainly with some negative and some positive, it's going to converge to an even smaller number. I don't know what it converges to. That's not what it converges to. It's just rough. But it converges. Yes.
So that's the same reason in the comparison test, when you suspect it converges, you go for a bigger series, right?
If there's an analogy there.
Okay.
If it didn't converge absolutely, we have to try an alternating series test. And this one, let's try the alternating series test if we can, and see if that also works. Because it might converge as an alternating series as well. Choice, or rather, condition one is one. And by the way, we don't really have to do this because we already have our answer. But let's say we didn't have our answer. So, does it pass the first test? What's the second? How do we show it? I agree. So therefore,
I like doing
You show that
first
each
term as the
absolute
second.
so
value.
let's look at a ratio, okay? And the ratio of the n plus first term over the nth term. So remember now, we really want to make sure that the value, the size of the terms are getting smaller, which really essentially means the absolute value of every term. Because if you had 1 minus a half plus a third, you might say, oh, this just got bigger. You're really seeing that the terms are getting smaller in absolute value. So if you didn't take the limit here, you'd be left with this expression, yes? And the key here, if you're doing u sub k plus 1 over u sub k, what do you want that result to be? Excellent. So the question is this less than 1? This result. And of course, k started at 1. At 1 already, it's less than 1. It's 2/3. At k is 2 or 10 or 50, whatever value k is going to end up being, this clearly is going to be
Right.
Yeah,
at one it's
not
one.
true at one.
It's not true.
Okay,
Is it a negative too, because you
no, there's no negatives. K starts at 1, then it goes to 2, then it goes to 3, then it goes to 4. Yes.
when you said that you have -1 to the k, and then you divide out, and then you have -1, it's absolute value saving, don't you still
I'm going to
have?
say what I said a few minutes ago again. Please listen this time because I answered that exact question. If you had this series, if I wanted to know if that series was decreasing, I would pay no attention to the signs. I would want to know if the absolute value of each term was decreasing. And clearly they are. If I paid attention to the signs, I would say, this is actually bigger than that. This is positive, that's negative. So in order to determine if a series is decreasing in size, we have to look at the absolute value of each term. In essence, we're going to ignore the -1. Okay? So it's true that it's equal to 1 and 1. And that's the only place where it's equal to 1. At every other value, it's less than 1. And if you ignore the first term of a series, what it does after that. Watch, this is going to make sense.
It's still
Does
decreasing.
this one look like it's decreasing?
Yes.
If I ignore the first term, 2 terms, would it still look like it's decreasing?
Yes.
If I ignore the first 50 terms, it would still look like it's decreasing. You can always ignore a finite number of terms. And if you ignore the very first one, it'll be okay.
But the tests don't necessarily have to work as long as you can tell that it's
You
decreasing.
know, you need to show this. If we're doing this to prove, we would say less than 1 for k greater than or equal to 2.
Okay.
Which is essentially almost every single k value.
Yeah.
And that's there, and we write therefore non-increasing. Really, we could say decreasing. So it passed the first test, it passed the second test. What's the third test? The alternating series test.
That's good.
It's supposed to be,
Zero.
so that's a problem for this one. Because we're getting infinity over infinity here,
How do you
Why can't we go from
Okay.
yeah? And I don't know how to use L'Hopital's rule here.
K is the next right?
I don't know how to find the derivative of k factorial. No, there isn't a waiting for them to get it. Is there another way to know what this does? What the limit is? This is an interesting question. So this gets big very fast, yes? Question is, does this get big faster?
Yes.
Yes.
I think it does, but I don't know how to show. For example, 2 to the third or 3 factorial, 2 to the fourth or 4 factorial. This already is greater than 1, and this is 16 over 24. This is already less than 1.
So it's only the first term that, or the first few that wouldn't be that way?
Maybe a proof
Yeah.
which is plugging in numbers.
That's not showing that the limit is 0. It's just I don't know how to show it. So I don't think I could use the alternating series test because I have to show that the limit is 0. And I don't have a way to show it. Unless I'm just missing something. Anybody have any ideas? Smart people. I mean, we could try the numbers and it would seem like it's getting tinier and tinier than it would. Somebody on your calculator, tell me what 2 to the 10th is, and then what 10 factorial. In fact, divide 2 to the 10th divided by 10 factorial.
Well, it's 1,024 over 363,628,800.
Pretty small, right? So it's very likely that it's going to get so tiny that it's going to tend to 0, which is going to verify what we found using the other method.
Wow.
But we can't really use this method. We can't use it. And it wasn't necessary here because we already used this first test.
If you
Okay.
started the other one,
If you started the other one, you get stuck at the point where now how do I show the limit is 0? You have to show it. You can't just say it looks like it. It looks like it to me. Okay. Any homework questions you wanted to ask? There was no homework? There was no homework. So we're done. I'm going to be giving out this tomorrow. Tomorrow is a really important lesson to be here for. I understand that we're not going to have a class on Friday. Clear as day.
And do we have it next week?
So, no, it's nothing next
no
week.
class.
Tomorrow will be our last class. Don't be absent for tomorrow's class.
Thank you.
Okay, you're welcome.